of Allah. The topic of our paper about a stock market prediction using multi-objective optimization. I am Mahshid Zolfaghari and other writers Dr. Hamid Fadishei and Dr. Reza Khoshkangini and Engineer Mohsen Tajgardan. Table of contents included introduction, background, architecture, data representation, and result. Financial market. Forecasting has been a challenging task and an important research area in finance and investment, both for investors and researchers. Related questions. Can the combination of two measures of prediction accuracy and correlation help to select suitable features for training? 2. Does removing a part of the features increase the accuracy and speed of the classifiers? The importance of the research. 1. The huge amount of data. 2. Existence of unnecessary data. 3. Many competitors and later decisions time. Targets. 1. Minimize the number of the selected features. 2. Minimize the similarity between the select features measured by Pearson correlation. 3. Maximize the prediction performance measured by AUC score. Background. Genetic algorithm, GA. The genetic algorithm is a nature-inspired search technique that tries to find the globally best solution in a search space. The reason behind the popularity of genetic algorithms is their excellent capability of finding near-optimal solution despite local optimum trap in the search space. Genetic algorithm is consists of the following steps. 1. Initial population production. 2. Fitness evaluation. 3. Selection. 4. Crossover. 5. Mutation. And 6. Stop conditions. XGBoost classifier is an efficient and scalable implementation of tree-boosting. This software package includes efficient parallel implementation of linear model solver and tree learning algorithm and supports various machine learning tasks such as classification, regression, and ranking. Furthermore, it's designed to be extensible and accept user-defined objective functions. Pearson correlation. Pearson correlation coefficient measures the degree of linear correlation between two random variables. The value of this coefficient varies between -1 to 1, where 1 means complete positive correlation, 0 means no correlation, and -1 means complete negative correlation. Feature importance. One of the feature selection methods is to use the feature importance concept. This concept refers to the methods used to score features based on their usefulness in the classification. One of the feature importance calculation method is tree-based models such as decision tree or random forest is the gene important metric. Architecture. The purpose algorithm aims at optimizing three different objectives: the count of select features, the classification performance, and the correlation between the select features. In order to optimize the three different fitness objectives, we use a linear weighted combination of them as a single combined objective. Calculation fitness function. 1. Calculation count features. Count the number of selected features as it should be minimized during the optimization. FSI refers to the selection decision of the features I in the feature set, which can be either 0 means not selected, or 1 means selected. Calculation AUC. The classifier performance used to predict two stock price trend obtained from an XGBoost classifier on the training dataset. The AUC metric is used for performance measurement. Since it's decide to maximize the performance, the inverse of the value should be used. Calculation correlation. The similarity score between all the features in the select feature set Fs, where correlation Fsj and Fsi refers to the correlation value between these two features in the training dataset, which can be a value between -1 and 1. Since we need to only use the lower triangle of the correlation matrix, the total sum is divided by the number of items in this triangle, which is m multiplication n-1 divided 2. Data representation. In this study, we use a dataset from the US stock market for 5 consecutive years from 2014 to 2018. The data of each year contains several thousand companies. For each set of 224 features are present. Our goal is to forecast the next year's performance of each stock based on various combinations of predicting year's training data. Table 1 shows an excerpt of the dataset for 2 different companies, GO to the excessive number of features. Only the first batch of them is shown in the table. Of the data present the colors of the company. It can be observed that one of the 2 example companies is this table in profitable and the other one is not. Choosing the base classifier. In order to evaluate the performance of the proposed feature selection method, we need to use a base classifier. On the one hand, such a classifier is desired to have a good accuracy level. On the other hand, it's required to impose as low training time as possible. This is because one classifier instance should be built per objective function evaluation, and thus the overall feature selection time directly depends on the base classifier training time. We measure the training time and accuracy of 7 candidate classifiers to select a base classifier. These classifiers were chosen from different types such as neural networks, hybrid methods like bagging and boosting, and other simple classifiers. The AUC obtained from each classifier over the last fourth of the dataset and the time spent on training each classifier are shown in Figure 3 and 4 respectively. Finally, XGBoost classifier was selected for having the highest performance and a good execution time. Experimental evaluation and results. Table 3 shows the AUC obtained from the proposed feature selection method compared to several other methods. The proposed multi-objective method results in a significantly better prediction performance than the compared filter and wrapper methods. It also performs better than the implementation that does not aim at similarity reduction. It is also essential to discuss the number of selected features and their correlation. The average Pearson correlation value between the selected features are shown in Table 4. It can be observed that the average similarity between the selected feature is comparable to other methods. The reason that in most cases the similarity is not better than other methods is the low value we chose as the similarity weight in fitness evaluation due to the more relative importance of prediction performance. Table 5 shows the average count of selected features. It should be noted that method 309 in this table always select a predetermined number of features. In order to reach a fair comparison, we set this number to be equal to the number of features obtained using the purpose method. The challenging problem of financial market prediction has been the focus of researchers for decades. Feature selection is an essential part of market prediction. Evolutionary algorithms are shown to perform well in this area. However, the time and resource constraints in a financial environment are a barrier to this algorithm's applicability to the feature selection problem. In order to address this challenge, we use the high performance and fast training XGBoost classifier in order to select the best features and build a prediction model upon them. We treat the feature selection as a multi-objective optimization problem. We made a minimizing the objective of model error kind of features and the similarity between them. We showed that such an approach could significantly reduce the count of features without sacrificing the model's prediction power. In Table 6, it can be seen that the purpose method in that field has obtained the best result in comparison with other algorithms. Thank you for your attention.